Okay, so we're now looking at working with equations with rational exponents. Now, rational exponents is in the fact that a lot of time when you deal with those equations where the exponents appear like 2/3 or 1/2 or 3/4 or something like that. And we also discussed the general forms of these equations in class. So here we're just going to simply do more examples so that you can see how we can get around with these equations. So keep in mind the ordinary form that you always need to bring your equation into is always one expression. That could be just simply an x or whatsoever, but one expression raised to an m over n power, and that's what we mean by rational expression. And equals to simply a number on the other side of the equation. That's the ordinary form. You need to always bring your equation into the ordinary form before you can start solving the equation. So now in my example number 1, we have an equation x to the 3/2 power equals 8. My equation right at the beginning, it's already in ordinary form. This form right here, once again we discussed that in class, but maybe it's worth it to mention again. It's in the ordinary form of the equation. So now my equation right there, right at the beginning, it's in the ordinary form. So now what I need to do is just simply check with the numerator of my power. The numerator of my power here is an odd number because I have 3/2, so my numerator is an odd number. So what I can do is to solve this equation simply, you're going to rewrite the x without the power. It comes to equal signs. The number 8 on the other hand side, the number on the other side of the equation, you're going to raise that to the power of 2/3. Now, what do I see here? What do I notice? The power that 8 I raised to the power, which is the reciprocal. I take the reciprocal of that fraction 3/2. So the power here is just 2/3. Okay, and since, like I mentioned earlier, the numerator of the starting out fraction here was an odd number, so you don't need to worry about. Remember that we discussed in class. We don't need about the plus and the minus here. So this is my final answer. So one step further, if you can evaluate what 8 to the 2/3 power is, then go ahead and go to the end. So 8 to the 2/3 power is the same as cube root of 8, and then you take the square power. So cube root of 8 is a 2, and square of 2 is a 4. So my final answer to that equation is x equals 4. Okay. So once again, in this example right here, you had an odd numerator in the power. Now, if you're looking at example number 2, okay, let's see how we can solve it. Another example here. And these are some of those easy examples. So, how about x to the 4/5 equals 16? So once again, question yourself, is my equation in the ordinary form yet? And yes, it is in the ordinary form. One expression raised to a fraction power equals to a number, and we're good to go. Okay? Now if you notice, in the ordinary form, if you look back, rewind to the beginning of the video here when I mentioned about the ordinary form, there's no coefficient in front. So in this one here, it's good. There's no coefficient. I mean, there's only a coefficient 1 here. And now, to solve this one, once again, I'm rewriting that expression without the power here, without the fraction exponents, and equals here. The 16 on the other side, I'm going to raise that to a power reciprocal of the other power. So now 5/4, 16 to the 5/4. But now, pay a little more attention here, because in this starting equation, the rational exponent that we started out, the numerator on that rational exponent is an even number. So now in my answer, make sure you have to put plus and minus. So my answer is x equals plus and minus 16 to the 5/4 power. And then if you can actually go all the way to the end to the final answer, that'd be good. 16 itself raised to the 5/4 power is the same as 4th root of 16 raised to the 5th power. And 4th root of 16 is actually a 2. And so 2 raised to the 5th power is a 32. So my real final answer is x equals plus or minus 32. Or it's really as x equals 32, that's one solution, and the other answer is x equals negative 32. So you end up with two answers. Now, either way, writing your answer is going to be just fine. Okay. Example 3 for all these rational exponents equation. And let's see. We have now 6x to the 5/2 power minus 1,458 equals 0. This equation, once again, I do see rational power. I do see rational exponents. But now my equation here does not appear to be in the ordinary form. So I need to work my way up to bring it back to the ordinary form before I can actually start solving it. So now, as usual, I'm adding 1,458 to both sides. Okay, and that leaves me 6 times times x to the 5/2 equals 1,458. Now, my question here is that am I at my ordinary form yet? Am I in my ordinary form yet? Not yet, because the rational exponents on the left-hand side, there should be no 6 here. I want to cancel the 6 away. I want only a single coefficient, single variable here. So now I need to divide the 6 away. So that leaves me x to the 5/2 power equals to 243. Okay, and so now this is where now I can say that I'm at my ordinary form for this rational equation once again, because the rational exponents on the left-hand side comes with with a singular coefficient, 1. Okay, just coefficient 1, leading coefficient 1 right here, and here is just one single number on the right-hand side. So now to solve this, once again, just simply do 243 raised to the 2/5 power. You switch over the fractions, and that's what it is. And then do I have to worry about a plus and minus? No, because starting in my beginning rational exponents here, the numerator was an odd number, so no need for the plus and minus. So here's my answer. Now, if you can actually evaluate all the way to the end, then we can actually go ahead and do that. 243 to the 2/5 power is the same as 5th root of 243, and we raise it to the square power. So 5th root of 243 is going to be a 3, and square of the 3 is a 9. So my final answer is x equals 9. And that's how you solve for that problem. It's in example 3. So example number 4, coming along.